Okay, so chapter number 19 is somewhat related to what we covered last time. Last time we talked about the populations, communities, biosphere, species, and these type of things. Things that are related to studying different populations, different species. And today we are kind of advancing that topic a little bit. We're going to talk about communities and ecosystems. So if you remember the definitions from last time, ecosystem is a combination of biotic as well as abiotic conditions. So all the living things and non-living things in a certain area makes an ecosystem. So ecosystem includes different organisms, different types of organisms, and which are called community. Then ecosystem is a combination of both of those, and ecosystems are part of the biosphere, which is our planet. Today we'll talk about the concept of biome, which is kind of different types of ecosystems. We have many different conditions on this planet. You know, there is ice on the two poles, then there are grasslands, there are deserts. So all of those are different types of biomes. Biomes are ecosystems. Different types of ecosystems are divided into biomes. Biomes have their own characteristic type of biotic communities as well as abiotic environments in them. So this is from chapter number 18. So communities are more related to a habitat. They live somewhere, certain location, certain area. They live in either on trees, they live in ocean, they live, you know, at the bottom or in deserts like that, you know, cactus or this damselfish or some fungi, mushrooms. They all have their own habitat. They live in that environment because they can find some shelter, like this fish is finding shelter in these kelps from California. This mushroom is finding shelter from sun because it is not photosynthetic, so it does not need sun. All that it needs is some nutrients. So it's living in that environment where it is protected under the trees, under the shade. Cactus that does not need much water grows in those areas which are deserts. So that is habitat of those different species, different populations. Then niche is somewhat different. Niche is not just the habitat, it is habitat with all other resources that are required for its survival, for its reproduction, and for its growth. So different species, they live in a certain habitat, but they need more than just habitat. They just don't need an area, like inside a house. You know, if you go inside a house, what you need a lot more things than just that building. That is the house. So that is, you know, the house is in a way a niche for you because you will change its conditions. You know, buy some type of furniture, you'll buy some decorations, and all those things are what really will make you more comfortable living in that house. So niche is something which is suitable for different species. And that includes all different types of abiotic factors, you know, light, temperature, and the different chemicals that are available for your nutrients. So that is a niche. And different organisms, different species, different populations, they have their own niche that they proliferate very well. They can grow very well in those. So when we talk about abiotic resources, which are, you know, sunlight, temperature, you know, water resources, wind, and all those type of resources that we need to survive in a different area, in a different niche, in a different habitat. So our Earth has many different types of climates, and the climate is a combination of, you know, again, light, temperature, moisture, and temperature is because of sun. Sun, you know, Earth is much smaller, sun is much bigger, produces radiations. So when we receive radiations from sun, it is in the form of heat radiation. Those are actually physical packets that we receive from sun. Those are photons. So when we receive those here in the form of light, in the form of heat, it does not strike over Earth equally. So this part here, which is the equator, which is the midline. So this equator, here in this area on the equator, the sun rays hit perpendicular. They hit straight. So whatever hits in this area is hitting straight, and it is being absorbed by the Earth. So it absorbs and then it reflects, and it radiates heat. So when we receive sun, the Earth gets warm, and then it radiates that heat also in the atmosphere. So about 15 kilometers of our atmosphere gets warm because of the heat that is received from the sun. Sun does not really heat much the air. It hits some type of object, which is Earth in this case. So Earth absorbs that heat. But as we move away from the equator, from this middle line here, those rays don't strike straight. So they actually fall at an angle. So the same amount of rays that are hitting the ground, they cover more area because they're not hitting straight, so they're hitting at an angle. That angle makes it to absorb in a larger area. So as you move away from the equator toward the poles, north or south pole, then this area becomes larger and larger because the rays are striking at larger and larger angle. So it covers more and more area. The same amount of rays are covering more area, so it becomes cooler and cooler because now you're not getting the same per unit area. So per unit area is decreasing here. It is the highest here, but as you move away in either direction, either toward the south pole or north pole, it becomes larger and larger area. So per unit area, you are receiving less heat from the sun. That's why the two poles are colder. And another factor is that another factor which results into different seasons. So this variation of temperature makes different organisms survive at different temperatures. The type of trees that you see on the equator are different than the type of trees that you see closer to the two poles. For example, in our area, which is not on the equator, so we are away from the equator. So we see different types of trees here. We see a lot of these deciduous trees. We also see a lot of those evergreen trees also. Animals that live here are different. Those animals that can survive the temperature during the winter and summer are the ones that are found here. But the same things are not seen everywhere else. As you move away and away from the equator, things keep on changing. So that is one way, that is the one reason that we have so many different types of organisms living on this biosphere, on this Earth. Another reason is Earth is not straight, it is actually a little bit tilted. Earth is not on its axis. It is not a straight Earth. It is a little bit tilted. It has a curvature. And that change from the straight axis, if it was straight, you would see these two lines, north and south pole lines, going straight up, upright. It is not. It is at an angle. And what is that angle? Anybody knows? What is the curvature, or what is this tilt of the Earth? Nobody knows? So that is about 23.5. So it is not straight. It is not at 90 angle. It is a little bit curved, and that tilt of the Earth gives us the seasons. So for example, in our area, we are cold, say starting from September till about February. And we have spring that starts after December. Well, it can start in December. The way things are now, it may actually start in January. Who knows? But it starts somewhere around March, and then it continues through summer till September. This is the season where we are warmer. And the reason for that is because we are on the North Pole. We are in the North Hemisphere. So this one is tilted during these months from March till September. So that part of the Earth is tilted toward the sun. Sun is in the middle and Earth is revolving around it, which gives us 365 point some days to go around it. So one kind of complete orbit is more than 365 days. It's 365 point something. So it takes about 365 days to complete a complete rotation around the sun. But then, what gives us the day and night? You probably have heard, learned about that in your other classes. So it's rotation around its own axis. That gives us day and night. So it is day when it is towards sun. It is night when it is away from the sun. At the same time, when we have this warmer season here, it is colder season on the other pole, because we are in the northern hemisphere, so we are warm during that period of time because our tilt is towards the sun. As we move away during September through January or so, then our rotation is such that we are actually away from the sun, and what is exposed towards the sun at that time is the southern pole or southern hemisphere. So they are warmer during that period of time. When we are colder here, it is warm season there. When it is warm season there, it is colder here. So their warm season is starting now. So we are ending our warm season and they are starting their warm season. So this is what is another kind of a reason for the distribution of different types of population, different types of communities around different parts of the world. So one thing which is kind of constant is these two parts, the two poles. The two poles are always very cold. Even during the summertime, when it is a little bit warmer for them, it is still very cold there because they are far from the sun, and sun does not hit those two poles straight. So the tilt of the Earth is the second factor. So the second factor, which gives us different temperatures and different seasons. So those are also kind of occupied. Those are also utilized by different types of species. Then this actually, this map shows us completely how temperature varies. So wherever you see red color, that means it's warm temperature, hot temperature, and the blue one indicates the cooler temperatures. So this is around the equator here. This is the equator right in the middle. So all countries that are located on the equator, where the sun rays hit straight, it is very warm. As you move away from it, it gets less warm, and as you move further and further away toward the poles, it becomes very cool. The temperature there stays very cool pretty much throughout the year, and it is always the same temperature here. The temperature here in the middle on the equator is always very nice. So it stays actually on the equator. It does not get too hot. It stays around 25 degrees because of some other factors, even though it should stay really, really hot. But actually the hotter areas are a little bit away from the equator, more close to about 30 degrees away from the equator, because there's not that much rain, there are not that many clouds that develop here, so it stays more warmer most of the year. So again, this tells us how the distribution of different species take place because of the temperature. All right, so the circulation. So one factor is the tilt of the Earth that gives us different seasons at different time of the year. Another factor is the winds, the circulation of the winds. The winds circulate in the form of these convection cells, and there are 6 of those cells, 3 in the northern hemisphere and 3 in the southern hemisphere. What those convection cells are, those are basically patterns of circulation which are related to heating and cooling, rising and falling of the air. So the temperature is different in different areas. So for example, on the equator, the temperature is higher. So what happens is the air warms up, and the warmer air becomes lighter air, then it rises. When it rises, the air which is cooler air replaces that air. So it rises above, and when it goes up, what happens? It is cooler there. If you go higher and higher, the temperature is lower. So as the warm air goes up, it actually takes more moisture with it. So warmer air has more capacity to contain moisture. So when that warm air rises, goes up, cools down there, so like when you go to mountains, it's cooler there. because you are on an altitude, above the sea level. So it gets cooler and cooler above. So when air goes up, it cools down, and when it cools down, it loses the capacity to retain the moisture that it has picked up from this water here. So rain falls in those areas. And this air, which is taking in this convection cell, actually drops the water on the tropics. So that's why most of the tropical rainforests are located on the tropics, because it gets rain, it gets tremendous amount of rain there. So in this part here, which is the lower part, that part is the one that does not really rain. That part is the dry part of the wind. So it picks up from here and then rises here on the tropics, drops the rain there, and then goes back. So as it drops the rain, it goes back because it is not covered with the water anymore, so it becomes dry. Comes down again and does the same cycle again. And same thing happens here, same thing happens here. So there is more rain in this patch here, which is the tropics, than there is no rain here in this area. That's why there are deserts located here. In Africa and other parts of the world, deserts are located here because there is no rain here, and these two lightly colored areas of the convection cells indicate the dry air. There is no moisture there. So those semi-tropical areas don't get much rain. Most of the rain is here. And then the next place where the more rain is received is this area, which is about 30 degrees away from the equator. So this area does not receive any rain. This area again gets a lot of rain, which is closer to the equator, 30 degrees away from the equator, and more rain falls in that area. Same thing on the other side too, on the northern hemisphere also. So this distribution of rain also kind of forms different types of biomes. So there are lots of rainforests here in all those countries on the land. So there are lots of rainforests there, and there's not much greenery in this area, not much greenery in that area. Those are all deserts in the form of small bushes and small shrubs and grasses and things like that. Big tall trees are here, which are evergreen. More trees are present very close to that, and not much present here. And then it is very green here, very green in that part, which receives more rainfall also. So it helps to distribute different types of species, different type of biotic resources, different types of living things. And another thing is the distribution or the movement of the water. So winds that help distribute the temperature also helps to cool down the water. So the water gets warmed up very close to the equator. So this is the line of the equator here in the middle. More sunshine there, so water gets warm, and then it gets cooled down from the water which is coming from the part of the oceans which are away from the equator. So this is the colder water that kind of mixes up with the water which is warmer and gets distributed. So these type of currents are flowing in different parts on different oceans of the world, in Pacific oceans, in Atlantic, in Indian oceans, which are bigger oceans. So this type of distribution of the colder and warmer water because of the sun again helps to distribute the temperature in these areas. So that's why the coastal areas are generally milder in temperature. They don't get too cold, they don't become too hot during the summer season. They don't get too cold during the winter season because of these type of distribution, these type of movement of the water inside the oceans is taking place. So these are the two factors. So when this thing is happening, that will also determine what type of species can survive here. Some of the species that survive in the coastal areas very close to the water are different species that survive in those areas. There are lots of animals that live in those areas very close to the coastal areas, and as the temperature is different in different parts, so different species are distributed based on availability of food as well as temperature. Another factor is the rainfall factor. So the rainfall is also not very equally distributed. Some areas get a lot more rain than the other ones. And one of the factors that determines that is the presence of these mountains. If there are big mountains present very close to the body of water, like different big lakes, Lake Superior or other types of Great Lakes, if the big mountains, tall mountains are present right next to them, what happens is the other side, which is the called rain shadow, does not get any rain because all the water that gets evaporated from the body of water here again rises with the warm temperature, with the warm build, becomes colder as it climbs up, and then this is the physical barrier present in between. As it is trying to cross that, the temperature is already kind of cooled down because of the elevation of the wind towards the higher altitude. So it gets cooled down and drops all the water that it carries there, and the other side really does not get anything. And that is the situation in many deserts. Actually, even in those areas which are very close to the body of water. So, like that example there, Andes Mountains, which separate Chile from Argentina. So there's water here, and this part, this part of the mountains is very green. Chile is very green, grows lots of grapes and other types of orchards. A lot of food actually comes from Chile because it gets a lot of rain. Being close or being present on that part of the Andes, which is called, the wet climate, which has the windward part or upwind side. So this receives a lot of water here in the form of rainfall, does not get anything on the other side. So everything is kind of dumped on the Chile side and nothing goes on the other side. That part is very dry and not much agriculture is done on the other side. Okay, so those three factors have to be kept in mind. One factor was the winds. The second is the distribution of the water because of the temperature. And the third one is the presence of mountains. So these three factors determine the temperature of the area. And temperature is one of the major factors that determines the presence of different types of species or distribution of different types of species and populations. Okay, now switching to the biomes. So biomes are ecosystems that have a very distinctive type of communities that live in them. So as if the whole planet has been divided into different biomes. These are different ecosystems, and ecosystems are a combination of both living and non-living things, and biomes are just characteristics of those ecosystems. And there are several different ones. For example, on the x-axis, it shows the temperature starting from higher temperature towards the lower temperature, and on the y-axis, it shows the precipitation, rainfall and snow, mostly rainfall. So as we go towards the poles, the temperature is very high. That biome is called ice. So because it stays frozen most of the year in the form of those big glaciers that are found there. If you move away from that, the temperature is a little bit less as compared to this temperature. So it's called Tundra. Coming more inland, it's called Taiga, and then there are grasslands, and then chaparrals, deserts. So and it has to be actually seen on both sides. So on this side is the rainfall, this side is the temperature. So for example, biome which is called desert biome, its characteristic is the temperature is very high and the rainfall is very low. So it is, and it's not only high temperature, but it is more related to the rainfall also, even though there are deserts that are present at very high temperature, like in Arizona, which is right next to California and Mexico. The temperature there is very high. And it does not get any rain. It gets rain only once in a while. So whenever it receives rain, then it actually gets it gets a lot of vegetation, a lot of plants that grow there. They flower during that time when it gets rain, and it's usually once in a few years that happens. So, but there are some areas which are not really very warm in temperature. There are some areas which are also called deserts where the temperature is very low. So, so that area is also called temperature because it does not get rain. So either it's too hot or too cold in combination with no rain. And then the areas which are rather more on the tropical side, like tropical dry forests, even they get a lot of rain, and those they still get a lot of rain. The temperature is very high, and then there are other ones which are called rainforests that are mostly evergreen plants. They stay green. They get a lot of rain there. So, and that is probably the best source of lots of different types of plants and animals living together, and that has not been explored completely yet. A lot of animals have not been even discovered that live in that area, and we actually find new species coming out of that area yet because it's so dense and it is so high in population that it has not been completely studied so far. Well, we may not actually get a chance to do that because we are eliminating those rainforests at a very fast pace, just to build new housing projects, a new industry, or new apartments, if nothing else. So we are destroying those, and we may never actually be able to find different animals that live there. Okay, so biomes are, again, those are ecosystems, or those are sub-ecosystems. They have very distinct communities that live in them. And ecosystems are a combination of two things, always. They are living things and non-living things. So that means biomes also have both of those things. They're living resources, which are their biotic resources, how they interact with other species, and how they depend on food on other species, and they also depend on abiotic resources, which are temperature, light, and different chemicals that are used as their food. And so these are different ones. We'll talk about some of those. These are different biomes. So ice, tundra, taiga, temperate grasslands, temperate forests, chaparrals, deserts, savanna, tropical dry forests, the temperate rainforest, and tropical rainforests. So there are temperate rainforests also. And this is taken from somewhere else. I think there is a similar picture in your book also. Maybe not. Oh, no, there's not. So this is taken from somewhere else just to show how they are located. Ice, again, very close to the poles or on the poles, and then a little away from the ice are the tundra biomes. Then conifer forests are close to the tundra. Temperate deciduous forests, we are part of that. Tropical forests are more closer to the tropics. Deciduous forests are a little bit away from the tropics. And then the mountain coniferous forests, and then alpine, and that is the end of most of these forests, so most of the biomes. Then starts the tundra and ice. There is a line beyond that. There is no growth. Like if you go to big tall mountains which are 6,000, 8,000 feet tall, or 6,000 to 8,000 meters tall, you actually don't see any bushes or any trees growing on them. So if any of you have ever gone to Mount Everest, you will see that there is no vegetation there. And that is only about 29,000 feet tall. So this is, again, taken from somewhere else to show where those things are located. Equator, again, 30 degrees north and south of the equator indicates that most of the tropical forests are located there. Since it's color-coded, it's not very clear here. But you can still see tundra, which are on both sides of the tropical, are located on the poles, very close to the poles. And all others are distributed in between. Different species and different species of plants and animals live in different types of biomes. This is what actually determines the biomes. The composition, which is the characteristic of the biomes. Each biome has its own living and non-living things in them. Okay, the very first one, the ice, biome ice, which is located on the two poles. By the way, why it's cold? Why it's cold on the mountains? Why people move towards the mountains when it gets cold and when it gets warm and hot? Why mountains are cooler? Okay, so why the higher up is cooler? Okay, what does above sea level do to the temperature? So what happens, you're right. So what happens is the sun rays strike, okay, let's assume this is sun. So it strikes the earth and then it is deflected, it is reflected from there. So when it is reflected, there is not that much in the atmosphere that can actually capture the sun rays. So atmosphere does not have much there. It has some particles, some air that does not absorb the radiations of the sun. So what really absorbs the radiation of the sun is the surface of mountains, surface of the earth. So when it hits the earth, it is reflected back in the atmosphere. So here the heat is high when it is hitting. So most of the heat is absorbed here. As it is reflected off the surface, it starts to lose its heat. Because now it is a different wavelength that is being emitted from the ground. So it loses its heat, and it loses that heat 6 degrees every 1,000 feet, every 1,000 meters actually. So 6 degrees are lost every 1,000 as you go higher and higher. So even if a mountain is only 3,000 feet tall, so there is still a change of about 6 degrees Celsius already. So if it is too hot, if it is say 36 degrees here, and that mountain will have about 30 degrees. 6 degrees is already better. So as it is taller and taller, as it is higher and higher from the sea level, it gets cooler and cooler. Because the sun is not really hitting straight again on the mountains. And mountains are not really absorbing much because it is still hitting them at an angle, and that angular, as we have seen, angular rays are not really warm, so they don't help much in the temperature. So for example, in case of those tall mountains that I talked about, like Himalayas, Mount Everest and others, which are about 8,000, 9,000 meters tall. So you can just see every 6 degrees. So if the temperature here on the ground is 30 degrees Celsius and a mountain is about 9,000 meters tall, so that means 6 times 9 is 54 degrees Celsius. So the temperature there on this mountain will be about 24 degrees lower. Minus 24 degrees will be found on Mount Everest. So that's the cooling effect. That's why the mountains are cooler. Mountainous areas are cooler. People move there when the temperature gets too hot. So on the polar side, on the polar or the ice biome, it is present on the 2 poles. Which one is called the Arctic? So there's one pole is called Arctic Ocean, and the other is called Antarctic. Which one is the Arctic one? South or north? North is the Arctic. So, and Antarctic is the south one. So we are located close to the Arctic one, North Pole. The temperature there are very cold year round. Precipitation is very low. They do get some precipitation there because they're closer to one of those convection cells. So since there's no vegetation, there's no local vegetation there because nothing can survive that extremely low temperature there. So they are kind of located close to the polar biome, which is the tundra biome. So they actually see some animals that live like bears and what else? Like seals live there. Some penguins live there. So there are some animals that live there, but most of them actually they migrate from the tundra, which is close to them. Otherwise, they don't have a whole lot of their own. So that shows that the polarized covers the land at high altitudes. So that is present not only on the poles, but on higher mountains also. Higher mountains also have an ice biome in them too, because they stay frozen pretty much the whole year round. Tundra, which are characterized by long, bitter, cold winters, since they are located very close to the ice biome, so they stay frozen. So this is the part. They are very close to the pole. This one is on the North Pole, so completely treeless biome, characterized by extreme temperatures. They don't have a whole lot of vegetation there. They do have some seasonal plants. Their soil is called permafrost. Permafrost means that even if the top part of the soil is not frozen during the summertime, the layer which is just below the top layer is frozen. So the top layer kind of melts. The top part of the snow melts during the summertime, but there is a layer of ice that never melts. So it kind of blocks. When this part of the layer, the top layer of the ice melts, the water accumulates here because underneath it's all frozen, so water cannot go down. So because of this layer of ice, that condition is called permafrost. It's permanently frozen. So permafrost means it is permanently frozen. So in tundra, there are no big trees, there are no big bushes that are grown there. Only seasonal plants can grow on the top layer after it melts during the summertime. So it does have some of those migratory type of animals that come there, some of the bisons that live in that area. Otherwise, most of the vegetation is just annual ones, small that have very short season. Some other types of caribou and some owls and other things can live here also. Their growing season is very short, so it kind of melts only for a short period of time, then it gets cold. Roots cannot penetrate much deeper because of this layer of ice that never melts. The next after those are called Taiga and Temperate coniferous forests. So those are conifers. Those are cone-bearing plants that are present after the tundra. So they are evergreen trees, like pines and firs and other types of trees, spruces and cypresses. There are many types of evergreen plants that live there. So even though they are not really very actively growing during the season, which is cold season, their winter, but they don't shed their leaves. Their leaves are very short and needle-like. And they don't shed their leaves during the winter time. Their winters are long and cold. Their summers are again short and wet. So because of melting of the snow and ice that they receive, then a part of this temperate conifer trees, there are some temperate rainforests which are located in kind of coastal areas in North America. So they are actually full of those conifers also. They receive a lot of rain and they stay green. They stay green because of the conifers, and they receive a lot of rain also. So this coniferous trees that we see in our areas that have a lot of these around on our campus too. So they can actually withstand temperatures, which are sub-zero temperature for many hours. They are not really affected because they do produce some proteins that are kind of anti-freezing proteins. So they can protect themselves by creating or making those proteins in their leaves that keep them protected from freezing. So when those proteins are produced, the same type of proteins or same type of mechanism is also found in those animals that survive in that area, like frogs, for example. Frogs, they hibernate. You will not see any frogs. If you don't like frogs, winter is the season for you. Because the frogs go down in the ground in some muddy area, they kind of burrow some hole, they go under, and they produce some of those proteins that keep them from freezing. So they're okay. They are almost dead at that time. There is no metabolism in their body. Same thing in case of snakes and bears and other animals that actually hibernate during the colder season. So these are some of these animals and plants that live in that area. So some owls, some foxes, and I don't know what this thing is. Maybe some type of member of some Ch19 family. I don't know. Some coyotes or something like that. Temperate evergreen rainforests, which are quite scattered on this earth. They are also very cold. They get a lot of rain, so briefly talk about those. They actually get a lot more plants and animals because they stay green. They get a lot of rain, they get a lot of sunshine also, so they stay green and have a lot more diversity. But they're not as diverse as the tropical rainforest, because tropical rainforests, the temperature is higher. In the temperate ones, the temperature is lower. It's not very low temperature, but it is still lower than the tropical areas. Temperate deciduous forests are the ones that are found kind of south of the Taiga and other parts of the world, like in Asia and Africa. They have actually 4 well-defined seasons. So where do we see 4 well-defined seasons? Do we see that here in North Carolina? We do see actually the 4 seasons here. So we are a part of that. Then we see actually the whole belt, which is this whole eastern side of the United States and the Middle East and all. That is all deciduous forest, temperate deciduous forest, because the temperature here does not get too cold or does not get too hot. Or theoretically does not get too cold or too hot. It can get pretty high during summertime. It can cross 100 degrees. It can get into the 3 digits also. And it can get very cold during winter. It can go up to what, -10. But which is very rare. Most of the time it stays much higher than that. Some of the tallest trees are found here in the form of these pines and others, but then there's a lot of other types of animals that live here too. A lot of different types of plants and animals, because there are 4 distinct seasons here. We have the 4 seasons, so that is the advantage we get here and in other deciduous forests. Some of the trees are evergreen, and other ones are deciduous, meaning that they lose their leaves during the winter time, and they regrow those leaves during the summertime. They look really pretty during the fall season with all those colors that we see, and those colors actually don't develop when you're living in tundra or in more colder climates. A lot of animals live there too. A lot of plants, especially during the springtime. So all of a sudden everything just wakes up, and it becomes pretty nice temperature, pretty nice vegetation also. Tropical rainforests. Tropical rainforests are present on the tropics. They are found in the equatorial regions. There is plenty of rain. A lot of animals live there. A lot of insects live there. Plants live on top of other plants. Epiphytes are those plants that live on top of other plants. So since there is, the environment is so good for their growth, so a lot of things can survive there much better. Soils, unfortunately, are nutrient poor because it is always populated with trees. So trees and plants are sucking all the nutrients from them. So they are not really very rich in terms of the nutrients, because it is so much heavily populated with trees and plants, because the rapid recycling of the nutrients there. And again, there is kind of a lush green and a lot of water because of the rains, a lot of trees, a lot of plants that live there, and a lot of those are not even explored at this point. The next one are the shrublands. Shrublands are the ones which are present along the coastal areas. that are pretty hot and cold. Hot during the summertime and cold during the winter time, like in California. Those shrublands in California that are called chaparrals, and those are the ones that are always known to cause some problem for the people because of the fires. So fires are common in those areas because the brush or the plants are very small in the form of grasses or small bushes, so that they die very quickly when they dry out. Kind of small kind of accidents, like somebody drops a butt of a cigarette or something, it catches fire and destroys lots of homes. As we saw actually this year, especially this year, it destroyed a big part of the Napa Valley, which is the California's best valley for grape production of the grapes. So the chaparrals are shrublands, and those are present to the coastal areas where the temperature can grow pretty high and where the rainfall is low. So a lot of those animals are seen there. A lot of deers and what is that? Can anybody recognize that? Meep. Roadrunner. You don't watch the cartoon programs anymore? I still watch it, so. The grasslands, temperate grasslands, again, those are no bushes, those are not even shrubs, so those are present those are the prairie lands, which are just the grasses. So there is some rainfall there with droughts and cold winters, and historically, here in North America, those were used for grazing by bisons and horses and others. So there was actually large populations of bisons and horses that used to live here, and deers and everything, because of those grasses. Those grasses would support very large herds of bisons, which were in thousands and thousands, and it is becoming much more limited now. But those are just grasses that are supported with the help of some rain that is received in some part of the biome. So those grassland biomes support some vegetation and some animals that live there. Savannas are grasslands that have some trees in them. So savannas, they are not very green. They are green only on the surface, but they are not very green in the form of tall plants or trees in them. Because of the presence of these brushes and of those grasses, they can also catch fire very easily. They are generally drier tropical areas with some non-tropical areas, and those are inhabited by large grazing mammals and insects. So like in Africa, so they have those zebras and tigers and lions and elephants in savannas. So people go on safari. We have actually destroyed most of those animals, but now we are trying to preserve them after we just kind of butchered them for decades. Now that we know that most of them are on the verge of being extinct, so now we are trying to protect them. That is a typical savanna. So you see actually most of the grassland with some trees in between. Deserts that are generally found at a latitude of about 30 degrees on both sides of the equator. So they generally lack rainfall, but they have some characteristics of some type of grasses and brush which are not very tall. So like we see actually in California, in Mexico, and on the border of Mexico, on the Arizona side, so we see a lot of those things there. They have some animals that live there. Mostly they are in the form of those reptiles and small type of rodents that live there. No large animals live there. So cactus is a characteristic of that biome. And we're just going to stop here, since I did not give you any break today. So we're going to just take that break now. Any questions?